Hello everyone. Am I audible?
Good evening. Yes, sir, you're audible.
Good. Yeah, good evening. Can you guys see me or the camera is not working?
No, sir.
It's blank.
Blank. All right. Give me a minute. Can you see me now?
Yes, sir.
All right. So everyone is clear about transpose of a matrix?
Yes, sir.
Yes, sir.
All right. No doubts from the last classes?
No, sir.
All right. Let's start with symmetric matrices. All right. Write it down. Give it. All right. And Aij equals to Aj I. That means A transpose equals to A. Then A will be a symmetric matrix. All right. If you interchange the rows and column, then the matrix remains same. All right. For an example, all right. Let's write. Let's find. Am I audible, everyone?
Yes, sir.
All right. If you interchange the rows and column, that is, if you find the transpose, even then the matrix remains same, right? If you take this row, write this in this
Sir,
column,
your screen is
then
not
this
visible.
row and this column. Screen is not visible. Is it visible now?
No, sir.
Give me a minute, all right?
Now it's visible, sir.
All right. Actually, I'm in my hometown and there are some network issues here. All right. So have some patience. All right. This will be going on for 2 weeks, I guess. All right.
Okay, sir.
Yeah, this is clear. If you find the transpose and the matrix remains same, then we'll call this a symmetric matrix. All right.
Yes, sir.
Hamza, is this a symmetric matrix or not? Sorry. Shikani, what about you?
Your voice is breaking.
Can you guys type it out? Your voice is not audible that clearly. I'm sorry for the disconnection. All right, am I audible now?
Yes, sir.
All right, if not, Krishna, is this a symmetric matrix or not?
Yes, sir. It is a symmetric matrix.
It is matrix, right? Symmetric matrix, because the A transpose is equals to A. All right, I hope this is clear to everyone. Symmetric matrix. All right, what is skew symmetric matrix? If A equals to Aij is a square matrix and Aij is equals to negative of Aji. All right, that means if you find A transpose, that would be equals to negative of, all right, then this matrix is skew symmetric. Okay, note it down. Did you guys wrote that down? Symmetric matrix.
Yes, sir.
All right, note it down. All right. For an example, if you take a matrix 0, 2, minus 2, 3, 3 minus 3, 4 minus 4. Can you guys try to find the transpose of this matrix? See what the result is. To find the transpose, what you get? What are you getting? What is A transpose?
Sir, it is equal to negative A.
Negative, right? So this will be 0, 2, 3. This row, first column, the second row in the second column, and the third row in the third column. So if you take the negative out, this we can write 0, 2, 3, -2, -3, 0, -4, 4, 0. So this is A matrix. So this is negative of A. So this will be skew symmetric matrix. Right? If you take transpose, then this will be negative of the first matrix. This is called symmetric matrix. Is this clear, everyone?
Yes, sir.
Yes, sir.
All right, Shivani. All right, my voice is breaking. Everyone.
Yes, sir. It is breaking.
A lot or a little bit?
So like a few times, like alternatively, sometimes it is clear and then it gets break.
Yeah, this I told you this will be the issue for next few classes. All right. Here, Shikani, see, skew symmetric matrix is if you take transpose then transpose negative of A. All right. Here, this was A matrix. We took the transpose of this matrix. This row in the first column, second row in the second column, third row. All right. So this to be the negative of the first matrix, A matrix. This will be called skew symmetric matrix. All right, symmetric was A transpose is equals to A. Skew symmetric is A transpose is equals to negative A. Is this clear? Shikani? All right. Now you can see one thing. For each element Aij in skew symmetric matrix, this is equals to negative of Aj, right? Symmetric. Symmetric, Shikani, symmetric is A transpose is equals to A. That means you take one matrix, find out the transpose, and that will be equal to the first matrix itself. Nothing will be changed. All right. So from here you can see, sorry, this is Aij. In skew symmetric matrix, all the elements are negative of the elements. That means Aij plus Aij is equals to 0. That means 2Aij equals to 0 for all these elements. Aii. That means Aii will be 0. What this means is all the diagonal elements will have to be 0 in skew symmetric matrix. All right, all the diagonal elements have to be 0 for a matrix to be skew symmetric, right? Because to take clear everyone? Krishna, Hamza, Shikhani.
Yes, sir.
Right. On the previous lectures. All right. Let's do some questions. If the matrix A is equals to 0, A, 3, 2P minus 1, C1, 0 is skew symmetric. Find the values of A, B, and C. All right, try to solve this one. All right, Shivani. Anyone has the answers? Krishna, Hamza,
Just solving.
solving. All right. Shivani, you can try. All right. I'll tell you the solution after 2 minutes. All right. Let's see. See, Shikani, the question is saying this matrix is skew symmetric. That means A transpose will be negative of A. So we can do that. Let's try to find A transpose. A transpose will be 0, A, 3, 2, B, negative 1, C, 1, 0. And this will be equals to negative times A matrix 0, A, 3, 2, B, negative 1, C, 1, 0. You can take this matrix this side. So this will be 0, 2, C, A, B, 1, 3, minus 1, 0, plus A, 3, 2, B, negative 1, C, 1, 0 is equals to 0. All right. You can add these two matrices. So 0, 2 plus A, C plus 3, A plus 2, B plus B, and this is 0, 3 plus C, 0, and 0 will be 0. Now you can equate, this will have to be 0, C plus 3 must be equal to 0, so C equals to negative 3, and 2B must be equal to 0, that means B is equal to 0. All right, this is the proper way to solve. Otherwise, you can just analyze. All right, see, if you take transpose, that becomes the negative of the previous matrix. So if you take the transpose, that means this will be negative 2. So A must be negative 2, C must be negative 3. B is the diagonal element, that means B must be 0. You can just analyze and find the answer also, if this is an MCQ. Is this clear, Shikani? And Hamza, Krishna,
Yes,
this is
sir.
clear?
Yes, sir.
All right. Shikani, this is not clear? All right. See, skew symmetric matrix is wherever A transpose is equal to negative of A. You have A matrix. All right, Shikani, what is, where are you confused? Which part? Just solve this equation. A transpose is equal to negative of A. You have A matrix, find the transpose. Transpose will be this 0, 2, C, A, P, 1, 3, minus 1, 0. Is this clear, Shikani? This step. First thing is to find A transpose. This is clear, Shikani? All right. Now this must be equal to negative of A because this is skew symmetric matrix. So negative times A matrix. All right. Now I brought this matrix to this side of this equation, added them and compared them. This 0 means this is a null matrix. And remember, if two matrices are equal, that means all the elements must be equal, corresponding elements. By comparing, I can find the answer. Is this clear, Shikani? All right, just remember this equation and solve this equation, you'll get the answer. All right, let's try another question. Given a skew symmetric matrix, A equals to 0A1 minus 1B1 minus 1C0, then find value of A plus B plus C whole square. All right, I'll give you 2 minutes. Hamza and Shekhani, have you solved this? 0 by 2, 0 or 1?
Sir, almost.
All right. Shekhani, 0 by 2 is always 0. All right. 0 by anything is all right. Everyone solve this?
Yes, sir.
Right. Hamza?
Yes, I do.
All right. 1 minute. All right. Hamza, send me the answers in the chat. Shekhani, solve this. Hamza, absolutely right answer. All right, 1 minute. I'll give you 1 more minute. Absolutely right, Shekhani. So I hope this is clear. I don't need to solve this. Right? Let's move ahead. One more question. Shekhani, this is clear how to solve? Matrix A is 0, 2b minus 2, 3, 1, 3, 3a, 3 minus 1. All right, Shekhani. Matrix is this is given to be symmetric matrix. Find the value of A and B. All right. Few minutes for this also. For symmetric matrix, A transpose is equals to A. All right, Shekani? All right, everyone solve this? Hamza, Krishna?
Yes, sir.
All right. So the value of B here will be minus 2 by 3, right? Krishna, this is clear?
Sir, can you repeat again, sir?
Yeah, the value of B is 3 by 2 and A is minus 2 by 3.
Yes, sir.
All right. So this is clear? No need to solve?
No need, sir.
All right. Let's move ahead. One short question. Which matrix is both symmetric and skew symmetric? Which matrix is both symmetric and skew symmetric? Any answers? Krishna, Shekhani, Hamza?
Sir, actually, the screen share, I think it's lagging, sir. We're still in the previous question.
Previous question. All right. Give me a minute. All right. Can you guys see it now?
Hello.
No, sir.
No. All right. Net is working fine, but now. All right. I can ask you the question. All right. You don't need to see this. All right. What matrix is both symmetric and skew symmetric? Can you think of one matrix which is both symmetric and skew symmetric? Krishna, you are not audible.
Sir, I think it's null matrix.
Null matrix. Absolutely right. All right. They may ask you this question in MCQ. All right, this is null matrix because null matrix is both symmetric and skew symmetric. If you multiply a negative sign, it doesn't matter. All right, and can you guys see the screen now?
So we can see the screen, but in the previous question still.
Still in the previous question. Give me a minute. Is it okay now?
Yes, sir.
All right. So this is all about symmetric and skew symmetric. Now there are some few important theorems on this. Theorem 1. All for a matrix A with real values, A plus A transpose is always symmetric and A minus A transpose is always skew symmetric. You can write it down. All right, write it down. You guys can see the screen, right?
Yes, sir.
All right, note it down. Done, everyone?
Yes, sir.
All right. So this is very easy to prove. All right. Take any square matrix and you can see this is true. All right. The next theorem is, all right, Shefani, the theorem is for a matrix A with real values. Yeah, you cannot read this. All right. For a matrix A with real values, A plus A transpose is always symmetric and A minus A transpose is always skew symmetric.
Sir, I think
Alright.
it's opposite, right, sir?
Let's see. So this is A transpose. A transpose will be 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Try to find A plus A transpose, A minus A transpose. All right. Find this, both of these matrices. The answers for this? Shikani, Hamza. Let's see. 8 plus 8 transpose will be 1 plus 1 is 2. 2 plus 4 is 6. 3 plus 7 is 10. 4 plus 6. 5 plus 5, 10. 6 plus 8, 14. This is 10, 14, and 18. All right. Now you can see if this matrix, let's call this C, then C transpose will be the same. Take this row, 2, 6, 10. This row, 6, 10, 14. This row, 10, 14, 18. So you can see this is equals to C matrix, right? Right. Can you guys see the screen? Am I audible? Shikhani,
The
Krishna.
screen is not visible.
So you're audible, but the screen is not visible.
All right, give me a minute. All right. The screen visible now?
Yes, sir.
All right. You can see A plus A transpose is this matrix. Now, if I take transpose of C matrix, I'm getting equals to C. So this is a symmetric matrix. If you try to find A minus A transpose, you will see we're getting the elements. 1 minus 1 is, let me write it here. D matrix is 1 minus 1 is 0. 2 minus 4 is minus 2. 3 minus 7 is minus 4. 4 minus 2 is 2. 5 minus 5 is 0. 6 minus 8 is minus 2. 7 minus 3, 4. 8 minus 6, 2. 9 minus 9, 0. Right. So this you can see is a symmetric, take the negative sign out, and this will go to the transpose of this matrix. Krishna, this is clear?
Yes, sir.
So take any square matrix that is filled with real values, and A plus A transpose will be symmetric. A minus A transpose will be skew symmetric. This is very important. Like they may ask you this in MCQ or 2-mark question also. Write it down. Done?
Done, sir.
All right. Theorem 2 is what this. You will be getting a long question. Any square matrix A can be expressed in the form of a symmetric and a skew symmetric matrix. I'll explain. Just write this. Change this in the form of sum of a symmetric and a skew symmetric matrix. Done?
Done, sir.
All right. So what does it mean? They are saying give me any square matrix A. All right. And I can show you two matrices. One is symmetric, one is skew symmetric, and I can write that matrix A in the form of these two given matrices. Why is this necessary? This is because in matrix, right, or skew symmetric matrix, you just have to multiply negative sign or write it as equal. All right. So this is very important for that. Let's see how to do that proof. We know that A plus A transpose is always symmetric. A minus A transpose is always skew symmetric. So can I write A as of A plus A transpose plus half of A minus A transpose? You can see if you simplify this, take LCM, LCM, here you will get A plus A transpose plus A minus A transpose. A transpose and negative A transpose is cancelled. This is 2A by 2. That means this is A. All right. This is A matrix. All right.
Yes,
We
sir.
know that this is a symmetric matrix. This is a symmetric matrix. So if you have any given matrix, and this we can see this is a different matrix. This is a different matrix, right? You can change that A into sum of two matrices. One is symmetric, one is skew symmetric. Is this clear, everyone?
Yes, sir.
All right, Shekhani. Shekhani, this is clear. All right, Hamza.
Yes.
All right, note it down. This proof also. All right. So everything is clear for today's symmetric matrix, symmetric. No, Shikani, any doubts? All right. This class is of 1 hour. Right. We'll continue from here in the next. Right. Please start NCRT also. Krishna, this is clear.
Yes, sir.
All right. Have you started trigonometry? Class 11?
Yes, I have started, sir.
Started. All right. Not finished yet.
No, sir.
All right. All right. Finish that as soon as possible.
Okay, sir.
All right. We'll continue in next class. All right. Today is 1 hour class.